A travelling salesman travels door to door, city to city, selling anything from brushes and hoovers to double glazing. It sounds like a straightforward job. But all travelling salesmen face the same question. What's the shortest route to take? So important is this problem that the Clay Mathematics Institute has offered $1 million for whoever can find an efficient algorithm or prove that none exists. The travelling salesman problem goes like this. Imagine you're a salesman and you've got to visit a list of cities represented by the red dots. The challenge is to find the shortest route, so you visit each city once before returning to your starting point. Now, you might imagine the best thing is to just consider all the routes, like this. The method of checking all possibilities is a type of algorithm. And for 3 cities, it works fine because there are only 3 possible routes to check. But what if we add 2 more cities to the list? With 5 cities, there are 60 different possible routes. And if we add another city, then there are 360 possible routes. And for 10 cities, there are over 1.8 million possible routes. If our algorithm chugged through them, checking all of these at a rate of 10 per second, it would take 2 days before it found the shortest. So you can see a method of trying all the different possibilities, a kind of brute force algorithm if you like, it's just simply impractical.
So if somebody found a fast algorithm for the travelling salesman problem, that would be hugely significant.
If one of my students came up with an efficient algorithm for the travelling salesman problem, I would get him to explain it to me. I would kill him, and then I'd go and claim the Clay Prize, $1 million. But I think my students are safe.
The problem crops up in lots of areas, from soldering circuit boards to planning the routes for supermarket deliveries. But has the travelling salesman problem secretly already been solved? A team of scientists working at Rothamsted Research in Harpenden have turned to nature to see if it has found the answer. They're carrying out an elaborate experiment to study how the travelling salesman problem is tackled by the bumblebee.
Bees have to forage for nectar in order to provision their hive. And so they have to visit possibly hundreds of flowers on each trip. What they want to do is find an efficient way to go between all these flowers that they visit.
The humble bumblebee faces its own travelling salesman problem. The flowers are just like the cities, and the bee is the travelling salesman.
One bee will go out foraging many times every day, so over the course of a day it really helps to take the most efficient possible route. So what we're doing is trying to figure out exactly what rules they're using to narrow down the possibilities.
Joe has laid out 5 feeders which play the role of flowers. Each feeder has just enough nectar to ensure the bee has to visit all 5 to give it a full honey stomach.
How are you actually knowing where it's going?
For this we're using harmonic radar. So as that spins round and round, it's emitting a radar signal. And we've attached a small antenna to the back of the bee which then reflects the signal from the radar. And so this allows us to see exactly where the bee has gone as she moves around the field.
So how does the bumblebee tackle the travelling salesman problem?
Okay, switching it on now.
With 5 feeders, there are a total of 60 possible routes. The shortest is around the outer edge. This heat map shows the path taken by a single bee. At first, it's simply discovering the positions of the feeders. Then, the bee appears to methodically change different parts of the route to see if it can make it shorter. Within 20 trips, it's honed in on an efficient route. This route is not always the absolute shortest, but for the bee, it's good enough.
That's amazing that just after a very few tries, they've got to something which is efficient enough for them to do their foraging.
Yes, that's right. They can't spend days or even, it could take months or years to try every possibility. So they have to very quickly find a route that they can do again and again and again in order to efficiently provide food.
Fantastic. I think the bees become my favourite insect now. So it's obviously a mathematician at heart.
Absolutely.
Let's be clear, bees are not about to be awarded $1 million. They've not miraculously solved the travelling salesman problem, because they don't always find the shortest route. But their algorithm is a clever approach. In maths, it's known as heuristics. Algorithms that are efficient, that don't find the perfect solution, but get as close as they can.